few 100 million years after the universe begins. The first true light switches on. The age of stars has started. Gravity, which is out across the darkened, starts gathering the first scattered clouds of Jacinto spinning. Glowing newborn galaxies threaded together by invisible filaments of gas and dust stretching across unimaginable distances. Dark matter, unseen but undeniable, quietly steers these infant galaxies into place, pulling them together into clusters that will one day span millions of light years. These enormous structures don't form overnight. Gravity locks them into a long, slow embrace, a gathering that plays out across hundreds of millions of years. As the young universe matures, it enters its most productive chapter yet, a golden age where stars are born at a rate 10 times faster than anywhere in the cosmos today. Most of the stars that will ever exist in the entire universe you're born during this single era, flooding the cosmos with light hat, will keep shining for trillions of years to come. Gravity is the master builder behind every great structure in the universe. But the very same force that gives stars their fury also would eventually unmakes them when massive stars finally collapse. They leave behind black holes, and over time, these grow in number across the cosmos. A handful grow far beyond anything else, swallowing the mass of billions of stars. These supermassive black holes settle into the centers of galaxies, quietly steering the fate of everything orbiting around them. From their cores, jets of particles blast outward at speeds approaching light itself. Any star that strays too close gets torn apart, destroyed by the same gravitational pull that gave every star its birth. Most stars in the universe are modest in size, and they'll eventually fade out quietly, without much drama. But a small fraction, roughly 1 in 100, carry enough to mass to end in a violent explosion instead. In that final explosive moment, a dying star releases every heavy element it spent its lifetime forging deep in its core, scattering the raw ingredients of life across space, and setting up an endless cycle of stellar death, feeding new birth. Out of that wreckage, new stars and planets form, enriched with heavy metals that didn't exist in the early universe, laying the groundwork for life to eventually take hold on the edge of our own galaxy. An unremarkable cloud of gas and dust drifts quietly in the dark for ages, until a nearby supernova sends a shockwave through it. Collapsing the cloud inward, gravity spins the material into a disk. The core ignites and a new star is born. Along with a battered, young planet that will one day become Earth. Early Earth is bombarded relentlessly by asteroids, a molten, hostile world wrapped in toxic air and scorching rain. But beneath the surface of its oceans, something unexpected begins to take shape. Mineral-rich vents on the ocean floor pump heat and chemistry into the water, and from that chaos, the very first living cells emerge. For nearly 3 billion years, this planet belongs entirely to microscopic life, an invisible empire that leaves no trace visible to the naked eye. Eventually, some of these microbes discover how to harness sunlight directly, and in doing so, flood the atmosphere with oxygen, triggering a planet-wide ice age. As the ice eventually retreats, Evolution shifts into a faster gear, with oxygen now available in abundance. Life finds access to far more energy, opening the door to far more complex forms of life than ever before. After billions of years, as solitary single cells, some organisms begin working together, merging into something greater than the sum of their parts. And as the last great ice age finally fades, life doesn't just continue, it explodes into astonishing new diversity.